Hi children, welcome back to the digital class of physical science of force lesson. Children, we learned in the previous session about force and types of forces. Let's take a glance on the previous concepts which we learned in the previous session. So force is a pull or push upon an object. Force is a pull or push upon an object. Force commonly classified into two types, that is, one is contact force and other one is non-contact force, or it is also known as force at a distance. Contact force, the force occurs on account of direct physical contact between two interacting objects, is known as contact force. Example for this is muscular force. Muscular force is involved in doing all actions like closing, opening, shutting, picking, hitting, lifting, lowering, pushing and pulling in our daily experiences. Non-contact force, that is force at a distance. Force that do not require any direct physical contact between two interacting objects, known as force at a distance. Children, we learned the example for this force at a distance are, see here, magnetic force. The magnetic force which is exists between two magnetic material are magnetic to the iron things which are separately placed. And the next example is electrostatic force. Electrostatic force is exists between two charged bodies which are separated by a distance. And the third example is, which we experience daily in our life, that is gravitational force, which is exist between two massive objects, and they are separated with a distance. So due to gravitational force only, atmosphere is surrounded by the earth. And see here, these are the three forces which are example for the force at a distance. Children, we learned not only force at a distance, we learned some different kinds of forces which we experience daily in our life, and those are very important for the force and a mechanical force concept. Those are frictional force, that is, friction is the resistance to the movement of a body over the surface of another body, and it is denoted by F, small f. See here, a push is given to the block, after some time it comes into rest. So observe here, a frictional force is developed between the two contact surfaces. Observe here, this arrow mark is opposite to the external force, means for frictional force is always developed opposite to the external force. And the next force is normal force. Normal force is a contact force which acts at a contact point and perpendicular to that point, and it is denoted by capital N. See, observe here children, a block is placed on the inclined plane, and this arrow mark showing the normal force direction. Why it is in this direction? Because of normal force is always act perpendicular to the surface of the contact surface, that is perpendicular to this inclined plane surface. So children, due to the normal force only, we are able to stand on the surface, we are able to sit on the chair. Without the normal force, we cannot stably stand on the surface. The things are not stable on the surface of any object. The next example is tension force. So the tension force is a contact force again, which developed along the string opposite to the external force, is known as tension force. So it is denoted by the capital T. So observe this picture children, a block of mass is hanged to a certain point with the help of a string. So on this block of mass, gravitational force is acting downward direction. So to oppose this gravitational force, there is a force developed across the string which is in opposite direction to the gravitational force. This force is known as a tension force. Children, these forces generally we experience in our daily life. Now Children, in this session we are going to learn about the effects of force. What happened after application of force on the objects. So see this here, the book kept on this table. So what forces are acting on this? So generally a gravitational force acting on this, a normal force is also acting on this, and also friction force is also acting in between these two contact surfaces, and the bottom of the book and the surface of the table. So like this, we know, children, we learned about the what forces, what different kinds of forces acting on the object at an instant. The next concept is force has a magnitude and as well as the direction. Force is a physical quantity which has magnitude and directions. So children, we are going to discuss about the direction of force. What is direction of force? For a better understand, let us do an activity. Take a look on this picture. So here a heavy wooden table kept in this position. So someone asks you to push this table and move this table from here to somewhere, and you try to move the table with your efforts, but it is not moving because of the wooden table is very heavy. Whatever you are applying the force is not sufficient. Then you ask your friend for a help to push this table, but your friend applied the force in opposite to your direction. So say the force applied by your friend is F2 and the force applied by you is F1. So both are applying the equal force. Observe here, both are applying the force on the table, but still the table is at rest. Why this table is still at rest? Let us calculate what is the total force on this table. So the total force on this table is, say it is as a F net force, which is equal to F1 plus F2. But why I am writing here negative symbol? Why I am taking for the force, second force, as a negative symbol? Because of this force is opposite to the first force, that is F1. So that's why I taken here negative symbol. So finally, so the resultant force will be F, plus into minus is minus, and F, because of F1 equal to F2 equal to F. Both are applying the equal force. So the answer is 0. Means even the forces are acting on this object, the net force will become 0. Due to this reason, the table still at rest. Means here the application of force, the direction is very important to change the state of the object. Let's then ask your friend to apply the force from your direction. So observe this picture. So you are applying in this direction and your friend is also applying the equal force in from your direction only. See the children, now the table is moving. So what is the total force acting on this table? So let us calculate. Say children, both are applying the equal force. Now the total force on this table is F1 plus F2, which is equal to F plus F, which is equal to 2F. So why the table is moved after the both persons are exerting the force on this table? Because of the resultant force is greater than the individual forces. The individual force is F. The resultant force is 2F, means the force is increased. So the application, in the application of force is, the direction is very important. The direction is very important. So observe this children, a block of mass, a block is kept here, and one person is applying force 100 newtons from the right side and the person is applying the force 10 newtons from the left side. Children, what happened when the two persons are applying the force, unequal forces in opposite direction? Yes children, it is moving in the direction of higher force, larger force. In which direction the higher force is applied, in that direction only the object will move. Now the question is children, what is the total force acting on this block? So what is the net force? What is mean by this net force? At an instant, each object experiences various types of forces in various directions. They may be in same magnitude, they may be in not same in the magnitude. So what is this net force? Net force is the algebraic sum of all the forces acting on a body is known as net force, and it is denoted by F net. The algebraic sum of all the forces acting on a body is known as net force, and it is denoted by F net. Children, so calculating the net force, before calculating the net force, we have to understand first what type of forces are acting on the object, in which direction the forces acting on the object, and what is the magnitude of those forces. To understand this, let's take a look on this picture. So the car is moving in this direction, children, due to the engine force. Say this is the engine force, which is denoted by capital F, and the red arrow mark is showing the direction of motion of the car. So now tell me, children, we learned in the previous session different types of forces are exerting on the object. So yes, the gravitational force, which is acting downward direction and indicating with the symbol W, which indicates the gravitational force. Now here the car has a two contact, we are observing the two contact points, so that's why two normal forces acting at these 2 points denoted with the N1 and N2, which are in upward direction. And another force is also exert on this car, which one? Which is invisible and which is always act opposite to the motion, and between the two surfaces, that is surface of the tires of the car and road surface. So this is the frictional force which opposes the motion of the car. So showing all the forces on an object at an instant, showing all the forces on an object at an instant, this diagram is known as free body diagram. This diagram is known as free body diagram. This is very important to calculate the net force acting on this object. So free body diagram. Now let us calculate the net force on this object. So how to calculate net force on this object? Take the help of coordinate system. Children, I think you have knowledge about the coordinate system. So this is a coordinate system. So we have a x-axis and y-axis. They are perpendicular to each other, and in this direction it is taken as a positive x-axis, this is a negative x-axis, and a positive y-axis and a negative y-axis. So you have to consider the positive for a force in the direction of positive x-axis and as well as the positive y-axis, and you have to consider the forces in the direction of negative axis, like negative y-axis and negative x-axis take as a negative forces. Now we have to calculate the net force on the object separately, individually along x-axis and as well as along the y-axis. Don't calculate, don't add all the forces like N1 plus N2 plus W plus F plus small f, like this. So remember children, it is very important to calculate the net force only along the x-axis and as well as the y-axis separately. Let us calculate the force on this car along x-axis. So observe here, the engine force is in the direction of positive x-axis and the frictional force is along the negative x-axis. That's why the net force on this object is engine force minus frictional force. Minus, why I am taking here minus? Because of the frictional force is acting along the negative x-axis. So this is the total, this is the net force acting on the object along x-axis. Now let us calculate the net force acting along the y-axis. So net force along y-axis. See here, normal forces N1 and N2 acting along positive y-axis. So that's why here N1 and N2 both are taken as a positive, and observe here gravitational force is acting downward direction, that is in the direction of a negative y-axis. So the net force on this object along y-axis is N1 plus N2 minus W. So children, in our worksheets which are given from the SCRT website, we have different types of problems are given and different types of tasks are given in the worksheet. You have to practice them. So for this, I'm going to explain a sample problem how to calculate net force on the object. So observe this question. Calculate the net force on a given object. A block is given. In this different types of forces, different forces are acting in different direction. So observe here. So 10 newtons, 85 newtons of force, 5 newtons of force, 25 newtons of force, and 5 newtons of force again. So these forces acting on this object in various directions, they are in different in magnitude. Now how to calculate the net force on this object? First of all, we have to calculate along the x-axis the solution. See, net force along x-axis. Only I am taking the forces which are acting along the x-axis, that is 25 newtons, 10 and 85 newtons. So here the 25 newtons is, see the arrow mark showing in this direction means that is negative x-axis direction. So the 10 newtons and 85 newtons are showing the they are acting in the direction of a positive x-axis. That's why 10 plus 85, 10 and 85, these two forces are in the direction of positive x-axis. So 10 plus 85 and the 25 newtons is acting along the negative x-axis. So minus 25. Now the total value is 10 plus 85 is 95, minus 25 is 70 newtons. So this is the force, this is the net force acting along the x-axis on this object. Now calculate the net force along the y-axis. So on this block I am taking only the forces which are acting along y-axis. Here the 5 newtons of force is acting along the positive y-axis and 5 newtons of force is acting along the negative y-axis. So the total force on this object is 5 minus 5, which is equal to 0 newtons. Means the 0 force is acting along the y-axis. This is the way, children, you have to calculate the net force which is acting on the object. So force is a physical quantity which has a magnitude and as well as the direction. So which has a magnitude means it has a units, like length has a units, centimeters, meters. So and like a mass has a units, grams and kilograms. Like that the force has also units. In SI systems the unit of force is newtons. In CGS system the unit of force is dynes. 1 Newton equal to 10 to the power of 5 dynes. Remember, children, it is very important in converting the units from MKS to CGS. So 1 Newton is equal to 10 to the power of 5 dynes. As of now, children, we learned about the force, types of force and the total force act on the object, that is net force acting on the object. Now we are going to discuss about what happened when the force is applied on the object. Observe this book, children. Observe this book. So on this book we already discussed it, that is gravitational force is acting, normal force is acting and as well as the friction force is also acting. But the question is, which force is responsible to keep the book in a rest state? Now observe this toy trolley. Observe this toy trolley. So I am pulling this toy trolley with the help of a string. So now the trolley is in motion. Tell me, children, what forces are acting on this? One is gravitational force in downward direction, normal force in upward direction and also a frictional force in between the wheels and the surface of the table, and as well as the tension force is also acting along the string. So now the trolley is in motion. So tell me, children, which force is responsible for the motion of the object? What happened after application of force? So let us discuss the effects of force. Now observe this picture, children. A ball is there, so which is in rest state. What happened when a push is given to this ball, or when you kick the ball, what happened? Yes, it's changes its state from rest to motion. Means force can change the state of an object from rest to motion. Observe this second one. So here the car is in moving. We want to stop this car. So how to stop the car? You have to apply the brakes. Means to change the state of motion from motion to the rest, we have to apply the force. Observe this, children. So the coins, what happened? What you observe, children? Before striking the coin, the two coins are in this direction. After striking the coins, the direction of coins are changes. Means by the application of force, you can change the direction of motion. Children, we have experience with the riding a bicycle. To increase the speed of cycle, you have to apply the force. To decrease the speed of bicycle, you have to apply the force. To take the turn, you have to apply the force. To do increase, decrease, or to change the direction of motion, you have to apply the force. Children, these are the changes after application of force. To change the state of rest to motion, to change the state of motion to rest, or to increase or decrease the speed of object, to change the direction of motion of object. So children, only these are the changes we observed. Observe this paper. Observe this paper, children. I am applying some force on this, which is in rest state now. Now also the paper is in rest state. What changes do you observe here? There is no change in the state. The motion, it is in rest only. After the application of force also, it is in rest only. So what the changes do you observe here? Yes, the shape changes, the dimensions changes. Observe this picture, children. When the force is applied on this cylinder, it changes its dimensions in the way like radius is increased and the length is decreased. Means by the application of force, not only the state of motion of object changes, but also changes in the shape and dimensions. So we have these changes may be a permanent or temporary. These changes may be a permanent or temporary. So you have to observe that the change is temporary or permanent. We have a table given in your textbook, and also it is given in worksheets of which are in SCERT website. Observe this table, children. So some action of forces are given here. Stretching a rubber band. Stretching a rubber band. See, children, a rubber band stretching, and after releasing the force, the rubber band regains the initial shape, initial position. When you stretch the rubber band, the shape changes and also dimension changes. When you release the force, it regains its original state. Means this change is a temporary change. And the next example is squeezing sponge. I am taking this sponge. I am squeezing the sponge. Yes, the dimensions and the shape of the sponge is changed here. But when you release the force, it regains its original state. Means this change is temporary. Now, I am taking the same paper. So tearing the paper. Tearing the paper. After tearing the paper, can we stick together? No, we cannot stick together. I am not a magician, so I can't stick. So tearing paper is also a permanent change. The next example is crushing plastic bottle. Children, if you crush the bottle, after drinking, you have to crush the bottle and throw it. And release the force. Is it regains its original state? No. So this change is also a permanent change. And children, making chapati. In our home, we daily do chapatis. So after making chapati, we cannot change it into previous state like dough. We cannot change into the dough. So this change is also a permanent change. And breaking glass, after when the glass once breaks, we cannot stick all the pieces together, we cannot make the new glass. So this change is also a permanent change. So children, we observed various articles which are made up of wood, metals, clay and plastic. So observe some things are given in this picture. So a wooden sitar is given here, and the wooden sofa and metal screws, jewelry and metal idol. So next here the clay articles are there, clay toys and clay articles, plastic bottles, plastic toys. Means to change the shape of the materials. To change the shape of the materials, we have to apply the force. So these are the effects for force, children. Now children, take your pencil in your hand. Take your pencil in your hand. Just push your pencil with the rounded end on your palm. What happened? What do you feel? Now push the pencil with its sharp end on your palm. It's paining. It's paining. Yes or no, children? It's paining. Why it is paining? So what is the reason? Let us observe one. Why the nails have a sharp end, and why the knife has a sharp end to cut the vegetables? Why not the nails has a flattened end? What happens if the nails have the flat end? Is it easy to insert those nails into the wall or a plank? No. So let us observe this picture, children, so to better understand. So here the two nails are given. So one is with a flat end, one is with a sharp end. What happened? On both nails I am applying the equal force. So when the force is applied on this nail, the force is distributed. The force is travel along this nail and exert on this surface area, which has a more surface area. The surface area is greater here. So here the force is distributed. That's why the effect of force is less. And observe this nail. So I am applying the equal force. Whatever the force is applied on the first nail, the same force is applying on the second nail also, and the forces are traveling along this nail. And here observe the total force is concentrating. The total force is concentrating at one point. So means in small area. That's why the effect of force is more. So this is known as pressure. The force acting perpendicularly on unit area of surface is called pressure. Pressure is equal to force by area. P equal to, in the mathematical notation, that is P equal to F by A. Units of pressure in SI system are Newton per meter square. Remember children, units are very important in our physics. For every physical quantity you have to mention the units. So let take a small. Let me explain a small example problem to understand how to solve the problems in physics. Children, if you learn the solving problems at this stage only, it will be easier to solve the problems in higher standards. Okay. So take a look on this question, children, which is given. So the surface of area of an object is 40 meters square and 80 newtons of force is acting on it. Calculate pressure on it. So to solve the problem, first of all we have to understand the question. So what is given in the question, what we have to find. And here in this question, the surface area is given as a 40 meters square and the force is given as 80 newtons. So we have the formula, we have to find the pressure, and we have the formula for the pressure, P equal to F by A, and substitute the values of the force and as well as area in this equation, that is 80 by 40, and calculate. So 40 to the 80, so the pressure value is here 2 Newton per meter square. Don't forget children, writing units. After completion of your calculation, you have to write the units. Okay. Children, in this session we discussed about the force, effects of force, and as well as the net force and the pressure. So let's take a just a glance on the review of concepts which we learned in this session. Force has a magnitude as well as direction. The algebraic sum of all the forces acting on a body is known as net force, and it is denoted by a F net. Force unit is newtons in SI system, dynes in CGS system. A force can change the state of motion of an object. Force may cause a change in the shape of an object also. The force acting perpendicularly on a unit area of surface is called pressure. Unit of pressure is Newton per meter square. Children, these concepts we discussed in this session, and try to solve the problems which are given in your worksheet which are in the SCRT website. So, and also I am giving some problems which is in your textbook also, and these questions are go through the textbook and solve the problems. The calculation, the problem is based on the net force, and the second one is drawing the free body diagram. Drawing free body diagram is very important. So when you know the what forces in which direction the forces are acting, then only you can calculate the net force. And also one problem is given here, that is pressure problem, and practice well and try to learn all these concepts. For better understand, some more example problems are given in your worksheet. Please students go through the SCRT website, and whatever in this session we are teaching one-way teaching, so there is no chance to discuss with you children. So please communicate with your teacher. If you have any doubts, communicate with your teacher and clear your doubts, children. Thank you, children.